So this is going to be definition of sparsity, sparse matrix analysis. Nikki, did you pay attention to the bottom links in Engineering 11 or Nemanja? In Engineering 11, did you see that I listed a bunch of numerical analysts on the bottom of that page? Tim Davis is a very, very famous numerical analyst who spent his entire career building sparse matrix algorithms. MATLAB has sparse matrix algorithms built into that. That's actually that is the current stage of the field. Sparse matrices are really, really special, and they deserve a lot of attention. That's well beyond the scope of an introductory class. But if you were to go to my Engineering 11 website and go to the bottom of that website and find the guy named Tim Davis, click on his website, you'll see a lot of cool stuff on that. That guy gets made a lot of money from industry because a lot of industrial companies like to use sparse matrices, and that guy has the premier algorithms in sparse matrices. Okay, so definition of sparse matrix. Let's let A be an element of R m by n. The total number of elements of A is denoted, we're going to say num L of A, and this is indeed a MATLAB function. So if you were to type in num L of a matrix A, it would tell you the number of elements. Could you guess if I have m rows and n columns, how many elements I have? M times n.
These were not in your lecture notes, right?
Say this again?
Sparse matrix. Yeah, sparse matrix.
The definitions are, I'm not going to, this definition is in my lecture notes. It's right, it's sitting there right there.
It's right there. It's
Yeah.
actually page 110.
The total number of non-zero elements in A is, could you guess what NNZ means? Number of non-zero entries. Yeah. To count the number of zero elements, we can calculate. Can you guess how you count the number of non-zero elements from these two?
Do we subtract them?
Yeah, so this would be the total number of elements minus the number of non-zero elements. We call a matrix sparse if the total number of non-zero elements in the matrix divided by the total number of elements is less than or equal to 0.10. And this is approximately. So there's not actually a formal mathematical definition of what sparsity means. But generally we say that if only 10% of the elements are lit up, we might call that sparse. The reason that this matters is the entire data structures associated with sparse matrices depend very, very heavily on graph theory. This is a major, major source of inspiration here. And then all of matrix analysis is done using different algorithms in sparse matrices because you're trying to minimize the number of fill-ins. And this was done in the 1970s and the 1980s, really. So this is kind of a useful thing to think about. But it is cool that we think about the number of elements and the number of non-zero elements, and we'll talk about that in just a sec. This is, what is a trending topic? Isn't there such thing as a trending topic in like Instagram or something like that? Or YouTube, perhaps? This is a trending topic in numerical linear algebra. Circa 1990s. It's a little bit older than a trending topic, but.
Wait, Jeff, when you say sparse matrix, the matrix is sparse?
A matrix that has very, very few non-zero elements compared to the total number of elements you expect.
There's like a data structure called sparse.
That's exactly right. That's exactly right. So you would use the data structure of sparse matrices to encode. Yeah. Which is kind of nice that you name them the same thing, right?
Yeah.
Yeah. That data structure is actually a set of vectors, right? A set of